Connor from Gitcoin. We're excited to get I'm really interested in what they're about to show off, so I'm ready for them to take it away. Thanks for joining, everyone.
Thank you. So I'd like to have a quick understanding of what's the level of depth of knowledge on Ethereum. So if you punch that on in the little chat box there, are you a beginner? Are you advanced? Are you like intermediate? That would help me there, frame the discussion. And also, I really appreciate if you want to stop me if you have any question, you can like punch unmute and then like interrupt me right away, or in the chat, obviously. So I'm Alexandre Bourget. I am the CTO at dfuse, and dfuse is a blockchain API company. So we build slick blockchain APIs. We make data access to blockchain data. So we make access to blockchain data easier, right? And so we're a bunch of serial entrepreneurs. A bunch of people here have built and sold companies. So we know how to make things into businesses that are long lasting. And that's our commitment to the blockchain community, to build something sustainable that will work and serve the people building on blockchain for a long time. So dfuse started as a sort of thinking from first principles how we would like to query blockchain data, to access blockchain data without being influenced by the different JSON RPC endpoints available, at the time. And to think through as developers, how would we like to access data? What sort of guarantees and reliability we would like? And that's how we built dfuse. So dfuse, just quickly, is a base layer platform access to blockchain data. Okay, so level one, I'm talking about blocks, transactions, state changes, balance changes, the sort of data at that level. It's not about the specifics of a single smart contract. It's base layer infrastructure. So we allow people to query, to search history, to listen on what's happening. And the dfuse platform has better depth of data than nodes themselves, because nodes expose APIs that are meaningful for achieving consensus, right? So there's a certain level of data that's available there, but dfuse brings you a lot more depth, for example, by indexing and giving you access to all the internal transactions. I don't know if that's something you guys are aware of. When you send a transaction to Ethereum, you have the first top level transaction, but that one, when it executes a smart contract, just like function calls, can call other smart contracts, and we call these things internal transactions. And these internal transactions can have millions of dollars being transferred, and there's very useful data there. So dfuse wanted to index and make available search and queryable and all that important data. Also, we have a lot more depth regarding balance changes, at which level, the reasons for balance change, the call stack, and all of that. And okay, so and we've also built it so that we have better guarantees. Right now, some people will query load balance load, like Infura, Alchemy, some other competitors there, and they will load balance between different nodes. The problem is that different nodes will have they'll be synced at different block heights. So you'll have a hard time finding the right piece of data. You're getting a block here, getting a balance here and there, and they're not the same. So it's difficult to have a coherent view, consistent view of a blockchain when you're querying a bunch of nodes. So at dfuse, we really thought, I don't want to live in a world like that. That's going to be always tricky. I need to write a lot of code to retry and make sure that I'm querying a node, I get a block, but then I did another query. I'm not sure I'm hitting the same endpoint. So it makes it very, very difficult. Right, so the dfuse platform is one holistic view of the chain state, right? Mostly for reading. There's a few writing endpoints also. You can help with tracking what's being written to the blockchain. And Dennis is going to talk about that, about lifecycle, right after. And he's going to give you some more concrete example as to how to use that, how the API reacts, and the sort of data you see through that. But from our early customers, people have said it's really cool because they were able to cut down 90% of their code, because all of that code written around client side was for retries, making sure that the data is consistent. A lot of the native on Ethereum, the native querying layer involves Bloom filters, and Bloom filters are data structures that can say, I am sure I have never seen X value, or I might have seen X value. So there's potential false positives. If you're looking for logs and looking for transfers, ERC20 transfers, you're querying Bloom filters. And what happens is that you need to query, and when there's a potential match, then what people do is they download the whole block, and then they check to be sure that this actually is a real match. And all of that imposes load on the code and network traffic on the client code. It's really annoying. So we didn't want to have that when we're building apps. And so, you know, when you search an endpoint, you search them for data, logs, or calls, because we do index also the calls and the values and the from and to and all these things, even within the internal transaction. Well, when you search for that, there's no false positive, right? It's legit results and it's solid. And we also provide cursoring for the chain. That is aware of chain reorganization. So when you query the platform, you come back with cursor, and it's just about the whole network, right? It's not which node you hit, because the cursor will allow you to keep and never miss a beat, even though there's some chain reorganization if you get disconnected and whatnot, right? So it's an extremely reliable way to access blockchain data and start building your app with a lot less code, really, and to make it reliable and to go to prod after, right?
So one question that I know we talked about, I think on the live stream before, but that I think has came up a lot is like how decentralized is this solution, and you know what are the trade-offs that you are giving for speed? In
right.
that sense?
So for speed, you mean?
Yeah, or I guess efficiency. You know, you said it's 90% less code. Right.
So okay, so two things. So we would think that there's a compromise because we cut code on your side, there's work being done on our side. But another feedback we've got is that, so we've designed our system, we started with some other chains that are very fast, 0.5 second, and that bulk, you know, a lot of transactions in some blocks. And so we designed all the system to be very real time, right? To be extremely, so everything in our system is like, there's nodes and it's pushing data, tack, 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 down to the user. There's minimal latency. We designed it for ultra low latency. So today what we see is that when you're getting a block or some transaction from a block through dfuse, you actually, some of our customers, they added a wait and a timeout of 1 to 2 seconds, because they would get the information from dfuse and then go to other providers to cross-check or something like that. And it would take 1 to 2 seconds before the other provider would respond with it, right? So the way we architected it makes it so it's ultra low latency, cuts down your code, and then it's Ethereum data, right? So if you want to cross-check, if you want to check, so we must understand that the crux of the decentralization is done by the nodes, right? And then when you're querying the data, well, there's always a layer that you then need to trust somehow, right? You're going to query Infura. It goes through HTTP. HTTP does not give you sort of guarantees that what you'll get is actually legit from the chain. So you always have that check you need to do if you really want to make sure that you know no system. At some point, you know, that layer, you need to trust a certain bit, right? But you can cross-check. And actually, dfuse is the first in the industry to boast what we call the Data Integrity Bounty Program. So it's in partnership with HackerOne. And if you find data that we emit, we can sign the outgoing payloads. And if you find data that is out of consensus, you're just wrong, then we will give you that value. And we want to increase the trust in that layer that is not cryptographically trustable in a way, right? So that's to the extent. And today, while the dfuse platform is a hosted platform, so it's easy to get started. You don't need to roll your infrastructure, but at the same time, right, that's the state of affairs today. Does that make sense?
Yeah, absolutely. I didn't know about that bug bounty. That's really cool.
Yeah, that's quite innovative. HackerOne hadn't seen that, and it's about the data itself. It's not about our systems. Of course, we also have, you know, security for our systems so that we don't no one comes and box the data. But okay, how are we doing on time?
Well, we can keep going for a bit just since we started late.
I'm going to talk for another 3 minutes, and then Dennis is going to jump in. Dennis is going to give you a good deep dive into concrete examples, right? How we use the API. You're going to see it flow, and this is how we use that. What's the endpoint if you want searching, whatever. Okay, so just before we go to that, I wanted to talk about one of the products. One of the products is search. And the search system allows you craft a small query, right, with ands and ors, and you can search on a bunch of terms on Ethereum. And we can search also in the log events, but not only the indexed log events, right? So if you have an event defined in your smart contract, you mark them as index. These make it so that they go in the Bloom filter, but we index everything. So you can search on the data parts that are not indexed by the chain, right? It makes it a lot useful. And this won't give you false positive. It's actually a real search. And we can search the whole history, sometimes in under a second, depending on your query. And this is the search that also turns out to be a real-time listener. So you can search for past blocks, and then you can start streaming into eternity, listening to new blocks that are coming through, right? With the same machinery, and the cursor works the same way, but the cursor near the head of the chain is fork aware. It's aware of the reorganizations. If you bring back the cursor, like, it can navigate fork for you, navigate reorganizations back for you. And reorgs are actually things that, if you look at Etherscan, there's a page there with reorgs. Each day, there are reorganized blocks. And some, I've seen apps like being built without thinking about that, and they just get off sync, right? And it's crazy if you want to, and then you need to write that 90% code to make it reliable in terms of, reorganization. This is a reality. Sometimes 2 blocks deep, sometimes 3 blocks deep. That's like each 1 month or 2 months, you'll have 3 blocks deep reorgs. And some other chains like Ethereum Classic had we've seen the 51 blocks, which is a crazy amount of blocks. So, you need to be ready. And the endpoint that we send you will send the undo signals just for the matching transactions. We'll send you a small undo, and then you can react to that. There's a last endpoint Dennis is going to introduce. Is about tracking the life cycle of transaction. So you go to the site, send $16 million, and you have no clue what's happening, right? Like, okay, 15 seconds has gone. The app is not reacting in any way. When we felt that, we said, oh, we need to have an endpoint so that developers can just connect to it with a transaction ID and be informed and just hook that to a small widget, right? So it shows a padlock, a color, whatever, something that the user is reassured that the app is taking care of them, right, for transactions. So that's the lifecycle endpoint. It navigates through all the state changes because, when you send a transaction, it's possible for you to send another transaction with the same nonce, with a higher gas fee. So the miner, what is it going to do? They're going to choose a higher gas fee. And when they put this one in, this one is sort of sent into oblivion. It's not going to be mined anytime because it has the same nonce, and nonce are monotonically incrementing. So you want to know that, right? You want your UI to be able to react to that and your users to feel good. And if they do a cancel, your app with a simple stream can drive them through that. So we think that's pretty useful. Dennis is going to go through the details. If you have any question, ask them right now. Otherwise, I'm going to be on standby. But Dennis, you're going to be in good company there. Go ahead.
So, can we run ETL-like queries on an endpoint, or maybe some things that you cannot do directly connecting to Web3.j, such as getting transaction history for an account,
Yes.
Going all the way back?
Yes. Absolutely. And so if you go in the search, so you right now, go to ethq.app. ethq.app is a small front end to the Diffuse platform, right? And this actually, the goal of that is not to make it your block explorer where you go see your token balances for end users. It's about the data of the chain, and it's merely a front end to Diffuse. It's just a skim. The power is in the Diffuse platform. And all you do in there, you can do through the Diffuse API. Actually, there's a little button to give the query to see the view there, so you can make it now a programmatic access. And in there, if you go to an account and click on an address, you'll see the query that's built there. And that gives a from and to, and with an or statement in between. And this means you're going to see all the transactions that were destined to one or from one address. And this indexes internal transactions. So actually, Diffuse is the only way today you can query for who calls your smart contract, even though it's done from within another smart contract, right? Because that's an internal transaction. So who calls the DAI project or sends things to DAI? You can't know if you query the node directly. But you do have that information now with Diffuse. Does that answer the question?
Yes, thanks so much.
Yeah. Okay, I'll let you in the hands of Dennis. Yes. One last.
Hey, what's up? I just want to know about the search. About what's the features we can use to integrate it in uh, an app, and what's like what can we do? Like, can we just, as you said, we can call functions in a smart contracts and something like that. Can we search for like
So a simple thing, and Dennis is going to go through that. Simple thing would be to search backwards in history and use the cursor and search into eternity and be sure to never miss a beat, right? That's sort of the thing that we pride ourselves to be able to do with 2 calls, and then one that is paginated, so you can continue in an infinity scroll that way, and then on that direction go into infinity with fork reorganizations, navigation, and extreme reliability. That's one of the easiest thing you can do. So with that, I'm going to hand off to Dennis. Thank you, Dennis. Sure. Thank you for all of you guys, and don't hesitate to punch any questions down there.
All right. Hello, everyone. Thank you for joining the dfuse workshop. So I'm Dennis. I am a software engineer here at dfuse and also ambassador because I come from a dapp development background. And so I'm here primarily to understand all developers' needs and what kind of features that you may have and to tweak and recommend our APIs to your needs. So that's what I do best. So if you have any questions, feel free to jump in, ask me anytime during my presentation. So thank you, Alex, for presenting the holistic view. It's always nice to hear so much knowledge that he has. But let me just start off by giving you the kind of quick start guide as to how to get started with dfuse. So let me share my screen here. And okay, so I guess you can see it. So on dfuse, especially for Ethereum, there are 2 features, 2 core products of ours that are very unique. So that is search and lifecycle. So in order to get started with any of them, you would first want to go into dfuse.io and hop into our docs, which is where you can get a free account for our API. So here, if you go into the guides and go to working with your free account, and lucky enough, because our service is hosted, you might think, well, I might need to pay for just to experiment around. But keep in mind that for my day-to-day, usage, experimental testing and demos, I use a free account myself, and I've never run out of, quota. So if you are just hacking or starting or building your side project, this will be more than enough to not pay a cent. So head out to our docs or app.dfuse.io. That is where you will actually log in with GitHub or your email address, and you can actually get a API key here with a page like this. And next step would be getting a JWT token, which you can send over through authentication headers in all your requests. And that's basically it. All of our APIs use the same format. And so after you've done that, I would recommend everybody to go into the next step here, which is exploring ETH through dfuse. So dfuse queries, most of them we really value the powerful GraphQL APIs and GraphQL schema and GraphQL search and queries. So there's this graphical tool on all of our endpoints called GraphQL, which is what I have opened here. So this is a tool to let you craft the query and pass in variables and to see the data in real time within your browser without running any sort of service or backend or frontend or running any code at all. So here we have some examples that are already favorited for you. So for example, you can stream a search, and here you see that we're searching with our query language non-zero values in transfers. And you can see the results coming back. You can also get transaction by hash or stream the incoming blocks, things like that. This provides a very kind of easy and graphical view for you to really see what you can do and sort of craft your queries before you get started. So that would be the next step that I recommend everybody to check out. And then the step after that would be, well, you're ready to dive in. So we have, first off, a JavaScript library called client.js on our GitHub. And this is a client sort of very built-in SDK where you can, craft queries and do all the things handled for you. And here we have a quick start example to get you quickly started in Node.js. And then we also offer our APIs over gRPC in basically any language that you can think of. So we have examples here for Go and Python, but you can do PHP or C# or whatever you have. So if you go into this tutorial here with search with query language, you can see in this GIF format what that would look like. So essentially you have this search box where you type in your query. For example, you can search for non-zero values, or you can search for methods by name. You can search for account to or from. And when you click a run search, this app will actually just show you the responses that was received that was actually matching your search on Ethereum mainnet. And you can either do this with GraphQL query, so you can pass it the limit and paginate it by cursor, or you can just let them come in one at a time in a stream. So both of these things are available through GraphQL. And you can go through the entire example here. And essentially it goes from helping you set up your key to the very end where you can have something graphical just like this in React that you can just build up upon. So if you have more usages on top of that, you can build on top of this repo. So that's search. And I wonder if anybody have any questions so far. Let me just check real quick. Will there be support for Rinkeby testnet? We have support for Ropsten, not yet for Rinkeby, but testnet, yes. Ropsten is what we are deployed on right now.
And the addresses, do they support ENS domains?
Not yet, but that is very, that is actually something I wanted to work on. And it's on the to-do list as I complete this hackathon. So if you really have some unique usages that you can see working, we can have that out very quickly. But not yet. But that is something that we see a lot of potential on. Is essentially just having part of our API as you can search by ENS domain or by the addresses even in the front end. But when the search results are returned back, we might parse it in our block explorer to show that as ENS domains. So okay, so that's searching, and next would be lifecycle. So what does lifecycle look like in Ethereum? Let me just show you very quickly on ETH for that. So if you go on our block explorer and get the latest transactions, and say you go into the newest transaction, you can see that there's one confirmation so far, and there are a bunch of states that's within, in between the point where you first submit your transaction to when it's confirmed. So typically in Web3, JSON RPC, you don't have so much information as to, oh, is it pending? Has it been replaced? Or which state transition has it just gone through? Because it could easily go from, say, in block back to pending, and then replace back to unknown. There's a ton of these state transitions that could happen, and we have a blog post for this actually on the 8 things that can happen to your Ethereum transaction, how to navigate them in your app. So this is what we saw as a big problem in Ethereum, and this is where API can solve. So here, how does this lifecycle work? So here we can actually run this query here just in GraphQL. And you can see that it comes in a subscription. So it's a constant stream. And as the state changes for your transaction based on your hash, the information that's returned actually changes. So you can see, you can have a real-time kind of reflection in your front end to say, okay, I sent the transaction, it's now pending, and then, oh, it's been replaced, or it's actually in block confirmed how many times. So this hasn't been done before, and in order to make front end dApps more interactive and in order to have more sort of reflection to the user and better user experience, we think this is a very cool kind of API to use for that. And that, as far as I've seen, not many dApps have even considered having so much user interaction. So if you can think of some usage in this, that would be really neat, and we look forward to what you can come up with. So back to the examples, this is again something that can get you started from zero to tracking lifecycle in React graphically, and so that's this tutorial here. And it works through crafting the query and setting you up in React with hooks. And if you want even more examples, we have more samples over here. We can set up, in Go, in Python, in TypeScript, more advanced features. You can use Apollo, all kinds of stuff. And if you have any more kind of usages or libraries that you think or languages that you think you want to work in, you can always reach out to us, and we have a very capable team to adapt right to your needs. And so that's basically the tutorials. And if you want more in-depth information as to the core features, so search or lifecycle, you can go into our docs and go to the concepts here, and you can find transaction lifecycle, which would explain this whole thing for you. So what can happen to your transaction state. And if you want to find what you can actually search, you can go into core concepts under guides, and there's the guide for the search query language that you can use for ands and ors and nots, true or false terms that you can use. And specifically on Ethereum, we can search for signer addresses, the method name or the method hash. We can search for nouns, to and from. All of these are listed here, and you can test that either in the tutorial repo that you build, or you can test that right on ETH here, just typing it in here. So for example, method transfer, and here you can get all the transfers search results back to you. And you can even craft your any types of queries with and or ors. So feel free to play with this a little bit more, and yeah, we would love to see what you can build. And does anybody have any questions for me or Alex that you can hop on the chat, or you can just turn on your microphone and we're here to answer questions.
I just want to ask, how do you track events? Just like, it's a little bit.
Events is we call them logs in this document. They're called logs, and all the, so Dennis, scroll up here, yep. The label. It says logs, and these are all the fields you can search in that exact page. In that page there. Yeah, scroll up.
Go.
So calls are EVM calls.
Yeah.
Right? The terms for calls, and then scroll elsewhere. I think logs are right after.
Yep, logs are down here.
These are the things that we have for logs. So you can search for logs on an address, and you can search for the topic 0 being the actual name of the log event hashed. And you can search for data sections also, data 0, data.1, and these will be the uint256 words of those data pieces. You can search for them. And I think we index 16 of those, if there are.
Awesome, thank you.
Yep, and when you're in GraphQL, you can even just open up the docs right here in Graphic Queries and test it out. So
and go back to that page, just a second. If you scroll up, those are 3 that are specific to logs, but there's some that are supported for both, right? So signer is the person who signed the transaction originally. So you can search for a log that would be produced in a certain contract, but signed by a particular person, and it can be combined like that. And for a particular method, like if the method was, I don't know, withdraw, and you're interested in only the logs that were produced after a withdrawal, then you can search for that too.
Yep.
That's amazing. That's pretty good. Thank you. Yeah.
Well, thank you. Thank you for the question. Just checking the chat here to see everybody else's questions. Yes, as Phil said, you can copy paste any of these examples to get started right away. Our examples are open source. So Andy asks, does it work for POA network for ERC 721 token as well? It definitely works for ERC 721 tokens because they're just contracts, as long as you have the contract methods that you want to search for, or you have their hashes. It's just works as any other contract. Not for POA network specifically.
So right now, POA networks, it depends what you're talking about. There's some different implementations of POA network. We could roll out diffuse on a POA network if it was, for example, based on Geth, and you guys, it's a standard Ethereum. If we're talking about other sorts of POA networks based on other protocols, we need to look into that. But if you're interested in a particular POA network, then let us know. Are you talking about Girly or some other public networks? then that may be possible for us to
Right now I'm using my private network by using the GEF as my Ethereum client. Yep, so I'm running a private network just to test, and I have a ERC-731 token contract to deploy the POI network. So just wondering, because there we have some difficulty on the getting some information from the blockchain here as well. So just want to wonder if there is any efficient way of retrieving the data, such as like recording the transaction history, etc. Yeah.
Right. Okay, so the current state of things is that we do offer on-demand networks for people who want more long-running POA networks, or networks that are like local or private or something like that. Okay, so we would deploy the dfuse platform. It's a complex, machine somehow. So we would deploy that for a certain network. But if you're in a hackathon running that locally, then you won't have access to diffuse locally for now. It's not said that it won't ever happen, but today you can't just plug out diffuse on top of your network on your machine. So it's unfortunate. And you can try working on Ropsten, for example. In the hackathons, a lot of people do that. You work on Ropsten, then you have all the automatic indexing and all the search capabilities that just come. We index the things live, right? So if you're on Ropsten, you'd be good.
Okay, thank you.
Awesome. I'm gonna stop share here, and thank you for always jumping in and answering any questions, Alex. If anybody else have any questions regarding getting started or technical aspects, or if you are wondering,
I have a small question. Like I'm very interested in the calls, like calling methods within a contract. Like it's a little bit like not clear for me, but it's very interesting. Like you can.
Right. Okay. So the state of affairs right now, we have an alpha feature doing that. I'm gonna tell you what it is. So you've seen that we have a GraphQL endpoint, right? It gives you access to blockchain. Yeah. It's not a Web3 drop-in that uses the same semantics, because it's more powerful and does more things differently that fit the Web3 JS, or the JSON RPC endpoints. Now, an important one in there is call, and we have an endpoint. If you look at I think it's called _alpha execute. And this actually does things slightly differently and slightly better, as you can specify a transaction you want to execute at a given block height, right? And it will speculatively execute it. So you can read out of it. You can take the return data. That's going to be your read call. But you can also speculatively execute a write operation. So you can put a transaction, and it'll provide you with all the stack trace, all the generated log events, all the state changes, the balance changes that would have occurred if that transaction would have been mined at that block height. So you can try it out.
Yeah. So
you
can debug things. Yeah.
It's alpha right now, but through GraphQL you can do that, pass the input, the method, the target, and from and to the contract, and you will get the full call just the same way you see them on ethq.app, but they're not graphically displayed this way. You have it in code.
Sure. Yeah. Thank you.
This is more of an alpha feature, but we would greatly value if you want to try that, because you can make things very special this way, right? Like execute a transaction each time there's a new block to see if you could, I don't know, gain a lottery because you would try it with those values. Yeah. I don't know. You can try stuff.
You can do a lot of things. Just like there's many possibilities with that. Okay. Yeah. Awesome.
We're good on time. Connor, do you have another thing after, or?
No, I'm all good from my end. So yeah, if there's no more questions, thank you so much, Dennis and Alex, for presenting. And hopefully we can get this up on YouTube soon for anyone who missed it or wants to reference. But yeah, thanks everyone for joining.
Thank you, everyone. Thanks for all those who attended and asked questions and participated. It's really appreciated.
Yep. And if you guys have more questions, you should be able to reach Alex or Dennis or Phil on Gitcoin chat.
Right.
So feel free to reach out, and we're looking
so Gitcoin chat will be there. And also we have a Telegram channel for a longer run, which is going to stay after Gitcoin for forever. And so reach us there too. Thank you.
Awesome. Thanks so much, Alex.
Thank you. Have a good one. Take care.
Have a good one, guys.
Thank you,
everyone. Have a good one, everyone. Bye.
Have a good day.
Happy New Year.